So now we're doing FreeCodeCamp Legacy Python for everybody, networking with Python. So we're actually into the good stuff now. Let's go.
Welcome to Networked Programs.
Well, thank you. So let's type that down to start with. Get out the old notes. Let's come all the way to the bottom. And let's type it out. I can't believe that summary was so short and was so not the usual summary, but whatever. All right, let's do that. Chapter 12, networked programs. Okay. And here we go. Let's see what he says.
This is chapter 12. Now we're going to learn a little bit about how we talk to resources on the network using Python. Now, this is a
free book on network architecture. We should write this down in the notes, even though we're going to do that anyway. A free book on network architecture. A free book on network architecture. There we go. For more detail, has more detail. Oh, it's his book. Whatever. www.net-intro.com. Okay. Nice little plug. Let's actually go there because why not? Calm down. All right. What was it? We should have just copied it. No big deal. Let's see if this thing actually works too, because that was ever so long ago. How the internet works. There it is. And it's still, it doesn't say it's bad, so there we go. drchuck.com. Okay. This site is being built as an open source educational resource to support his textbook on TCP IP network technologies. He's also exploring a new approach to building remixable OER materials. Okay. We can see the course code for the book in his GitHub repository. Okay. Feel free to submit a pull request if we find something that needs fixing. Thanks in advance. Okay, I don't know what any of that means. All right, so there we go. It goes to this. Awesome. So let's keep going.
Really quick introduction to how the network really works. I have a whole book that I wrote. It's also translated into Spanish on how the network works, starting at the very.
It looked like it was translated in like 6 languages. What was it called? Net intro. Boom. 1, 2, 3. Spanish, Greek, Russian. No, so it was 3. 3 languages. And 4 if you count English. What a. It must be that good, honestly. We might have to go into that.
Very lowest layer packets and everything right on up. And it's actually really easy to read. I wrote it for a high school audience. It's a short book and pretty easy to read.
I believe it. All right. Transport Control Protocol. I've seen these letters before. I didn't know that's what that meant. All right. So let's do this. What did it say? Let's get there. Transport TCP. Okay, I don't remember. Control Protocol, of course. How could I forget? Control Protocol. Okay. And then it's TCP. TCP like that. Okay, so what this is, it's built on top of IP, which we didn't talk about either. Built on top of IP. Internet Protocol. Okay. What else we got? Assumes IP might lose some data. Okay. Stores and retransmits data if it seems to be lost. Okay. Handles flow control. Okay, using a transmit window. Using a transmit window. What does that mean? I don't know. Provides a nice, reliable pipe. What does that mean? Also, a dice reliable pipe. How about nice? How about a little nicer? Okay, I don't know what any of that means. We also have this. Let's look at that while we're here. Peer-to-peer, application, transport. I don't know what that means. Internet, link, Ethernet, link, internet, fiber, satellite, etc. Link, internet, Ethernet again. Link, internet, I don't know what that is.
So if you read that book, you will understand that there is this layered architecture, the TCP architecture that sort of runs our network. At the lowest layer, that on one side here, this is your computer and this is a server computer. And if you sort of want a web page, it goes across the network, does this like 15 or 20 times, then it goes up into the server, reads the data, and then the data comes back, 15, 20 hops for the packets, and then it's shown to you as what you see. And so that's how it works. And there's these layers that we're not going to talk about in this section, but I talk about in that book. The layers of the link layer, which talk about how to get over one hop. The internet layer, which talks about how to construct, say, 15 or so hops to get packets back and forth.
Hops.
That's the sort of lower level bits. We're going to start at what we call the transport layer, and that's the layer where your computer sort of assumes that it can make a phone call to another computer, another process running on a program on this computer, talks to a program on this computer, and then it kind of comes back. Okay, and so we're gonna leave this alone. We're going to ignore it. We're going to assume that there's this nice reliable pipe that's going from point A to point B, and what are we going to do with the pipe? But if you're interested, take a look at the book.
Okay, I see.
So
I see. Pipe. Nice, reliable method to transmit information online. Boom. That's a little bit fewer characters, a little bit more. You know what I'm saying. And what is going on here also? Why are they got those?
Just going to start with a pipe, some kind of a connection. We have two processes, process, and we have some kind of a connection between them. And it is a connection that we can both use to talk and to listen. In nerd terms, we call these things sockets, and that is one process running on one computer, another process running on one computer, another second computer connected through the internet somehow, and one computer speaks into that socket and it comes out, and the other computer returns something and it comes. And so this is a bidirectional protocol of data, which is a series of, in effect, data phone calls between applications. So,
okay. Before we get too many more secrets that we can't process all at the same time, let's type this down, because that was one ear out the other. All of what he just said. He was like, I can't hold it in, this jargon. I need to tell somebody words they don't know or I will die. That's how it feels, isn't it? Anyway, let's try to simplify this. In computer networking, all right, an internet socket or network socket you know what is an endpoint of a bidirectional bidirectional inter-process communication flow across an internet protocol based computer network such as the internet. It's so stupid, but anyway, let's drop this down and let's go give my buddy ChatGPT a little work, because it's almost as if they just don't know how to speak regular person at some point. They just want to revert back to their jargon speak. But you know, that's how it is. That's how it's been. This isn't ChatGPT by any stretch. Let me pull it over here. ChatGPT. All right, bring it back on over here. Get rid of this. Let's bring this back up. And let's tell ChatGPT, simplify this. All right, let's see what it's got. It has an internet socket or network socket is a connection point for two-way communication between devices over an internet-based network like the internet. Internet-based network such as the internet is kind of a stupid thing to say at any time of day. You're right. That phrasing is redundant. An internet socket or network socket is a connection point for two-way communication between devices over a network using internet protocol like the internet. Let's just leave the like the internet off. We know. Okay. Anyway, so let's take everything before this comma, copy that, come over here to our handy dandy notes, slap it in like this, drop it down like thus, and look at that. We've got a sentence that isn't ridiculous. All right, let's go back over to Let's Learn Python and listen to him jibber jabber some more.
The application might.
Yeah, okay, that makes sense too. All right, let's put that in our little notes. Let's do this. Let's say process. We'll have some arrow action. We'll have internet. We'll have some more arrow action. Process. There we go. All right, so now let's go.
Be on your side, this might be your browser. Chrome, Firefox, Internet Explorer. On the other side, this is a web server. Might be Internet IIS, Internet something from Microsoft, or Apache, or Java Tomcat. There's another program, and you are making phone calls between these programs. Now, in general, these servers here stay up all the time, and you sort of just can make a request when you feel like it on in your program. But that's what we're going to do, and this is what we call a socket. So that little connection, that phone call, that data phone call, is what we call a socket.
Okay, so that's so stupid. Why didn't you say that in the first place? Socket is basically the connection from this end user to a server. Vice versa, etc. Okay, so there we go, etc. Because you know, it can be a server to a server, it could be a user to a user, it could be a blah, 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 blah.
Now,
oh look, we've got some more stuff to write down. What does this say? TCP port numbers. Okay. TCP port numbers. All right. I think we've seen these before in our computer days. A port is an application specific or process specific software communications endpoint. I hate that sentence too, but I think it's just going to keep going deeper and deeper into this nerd speak. We're going to have to use ChatGPT more and more. It allows multiple networked applications to coexist on the same server. Okay. There is a list of well-known TCP port numbers. Okay. So a port is an application-specific or process-specific software communications endpoint. I don't know what that means. Let's go ask ChatGPT, because this is too much. It's too much. Too much jargon. Too much jargon in one sentence for beginners. Simplify this. Simplify this. That's the same. That's that's reworded. What's an endpoint? Endpoint. It's the specific location where communication happens between two devices or processes in the network. Okay. It's like a door through which data enters or leaves the system. You didn't have to say that. All right. An endpoint is a specific location where communication happens. Okay, so that's what they're talking about. Okay. It allows multiple networked applications to coexist on the same server. Are they talking about like when multiple people are using the same application? Is that what that means? Is that what that means? All right. Let's go over here. We're already here.
You have to.
All right. So it allows multiple networked applications to coexist on the same server. What does that mean? Simplify this. It allows so did I type that down already? I could just copy paste, right? There it is. All right. Simplify this in regards to that. In regards to that. Okay. It lets multiple apps use the same server at the same time. Why didn't you just say that in the first place? There is a list of this. Okay, so a port is an application-specific. A port is a software endpoint used for communication by a specific application or process. Okay. So the port is the... What is it? Whatever. The port is the actual what?
To decide which of the systems you're socket. So that little connection, that phone call, that data phone call, is what we call a socket. Now, you have to decide which of the systems you're going to talk to and then which of the services on those systems or which process. And so we have this concept called port numbers, and they're best thought of like extensions on phones. So one organization has one phone number and says, please enter the extension of the party you'd like to talk to.
Okay.
Well, that's kind of what ports are. They're like, here is, I'm a server and I'm connected to the internet. Please enter the extension of the process that you would like to talk to. And so, for example, there might be...
Yeah, we're not typing this down, but we can look at it. All right, let's listen to him.
Processes running on various computers. And so the email is known to hang out on port 25 or extension 25. Insecure login lives on port 23. Insecure web lives on 80 and secure web lives on 443. And there's a couple of different protocols. Say if you have your mail stored on Gmail and you have a local mail client, say like Thunderbird or Apple Mail, that talks a protocol to pull that mail across. And those live on various ports. So these ports are those extensions. And by convention, we have standards that tell us what to roughly expect at those ports. So when you're talking to port 80, you expect to talk to a web server or an HTTP server. If you're talking on port 23, you expect to talk to a telnet server, and on and on and on and on. And so these are the extensions, the typical, commonly used default extensions for various network application processes that are serving us data.
Anyway, I do the same thing, but you know what? It's still inexcusable. All right, so what is this? Common TCP ports. Common TCP ports. Okay. So we've got telnet, which is login, and that's going to be 23. What else we got? SSH. What is that? I don't know. SSH. We'll get into that later. How about that? That's going to be on 22. And since we're going to be, okay, secure login. Okay. So let's have a little bit of this action. The space, the parentheses, and the, let's go with this. Let's fill it in. Let's take this, copy it, put 23 in here. Actually, you know what? Let's take this right here up to here. Actually, you know what? Let's do this. Let's copy this. Let's undo that. Let's throw 23 in here. 23? 22. And then let's drop this 1, 2, 3, 4, 5, 6, 7. 7 times. 1, 2, 3, 4, 5, 6, 7 times. We'll start here and say HTTP. Okay. Then we'll have HTTPS. So that's secure. Hypertext, whatever. SMTP. What's that? I don't know. IMAP. What's that? I don't know. We'll get into that later. POP. What's that? I don't know. We also have DNS, domain name something. Okay. FTP. Okay, file transfer. We've got a 21 here. We've got a 53 here. That's a 553 here. POP is going to be 109 and or the 110. Okay. Then we've got a bunch of them. 143. Which one is? Okay, there it is. 143.220.993. Okay. SMTP is 25. And we've got 443 for secure HTTP. And we got 80 here. Okay. We don't have anything here. We've got secure here. We've got mail here. All right. We got mail retrieval. Whoops. Mail retrieval. Okay. We've also got some more mail retrieval. Okay. And then we got domain name. Domain name. And then we've got file transfer. Yeah, this is the kind of stuff we're going to have to we'll get this in time, but I don't think we can just force this stuff in our heads. You get what I'm saying? Maybe you can, but I don't think so. I think we're just going to have to see this over and over and over and just intuitively figure it out. But let's keep going.
Now sometimes you'll go to a URL and you'll see in that URL there's a colon and a number. That means it's a web server that's running on a port other than the official 80 or 443 port. Now, in Python, we can talk to these sockets.
Okay. Do we need that? Yeah, let's write this down. Let's write that part down. Let's write that down right here. And where should we write this? We'll just write it here. It doesn't matter. Right here. Sometimes we see the port number in the URL if the web server is running on a non-standard port. Okay. And for example, we'll write that. Lassi Asia. I don't know what that is. Let's do it here. Let's say www.lassi-asia.org. Let's just put website.com. www.website.com. And then we would have port 9090. It doesn't matter. And then words. All right. So that would be how it would look, basically. All right. So now let's go.
3 port. Now,
let's type this down. All right. 501, 744, 26 minutes. That's not bad at all. All right, let's go. So, pardon me. What does it say? Sockets in Python. Let's do that. Sockets in Python. Python has built-in support for TCP sockets. Okay. So we'd have something like this. Import socket. My socket equals socket dot socket. Okay. What is this? Socket dot AF inet. Okay. And then we're also going to have socket dot sock stream. Okay. My socket. Do you have to put my sock? Is that no? That's a variable we literally just made. Dot connect. And then inside here we're gonna have another set of prints, and then we'll have data dot pr4e dot I thought it was pi for dot org py for all right, comma 80. Okay, what? All right, let's hear what he has to say.
Python, we can talk to these sockets, right? We can just talk to them, and it's really easy, surprisingly easy. We have to import socket because that's a library. It comes with Python, but until you can use it, you can't use it in your program until you say it. And then you basically in the socket library you call socket function. That's what that syntax is saying. You're making a socket. Now the key to a socket, it's sort of like an unopened file handle. It's half of a file handle. It's an outward looking thing that's not yet connected. These parameters, you're just going to type them in. This says we're going to make a socket that goes across the internet, and it's a stream socket, which means that it's a series of characters that come one after another rather than a series of blocks of text. There's another kind that's harder to deal with, but we're going to do this. So this, don't worry about this line. Just know that this creates a socket but does not associate it. The very next line, we get back a socket object in this variable that I'm storing in the variable mysock. And then when you want to make a connection across the internet to the far end, you say, oh, hey, dear socket, extend yourself across the internet. Make the phone call to this host, data.pr4e.org, and on that port 80. So that's making the phone call. This is like the phone number, and this is like the phone extension. So we haven't sent any data yet. We have simply rung the phone of a process, hopefully living on port 80. If it's there, great. This might blow up. This one here won't blow up, but this line here could blow up. If there's nothing sitting on that process, it would come back and say, oh, you tried to call, you got no answer. That's a legitimate thing to happen. Maybe you don't have a network connection, or maybe that service is down on that server, or the whole server's down. But so it's kind of amazing that we're sitting here in Python, and in 3 lines we have probably 500,000 engineers have built this thing called the internet, all these protocols and all this software, and we just made use of it in 3 lines of Python. And I guess this is one of the reasons that people absolutely love Python. Absolutely love Python. So now that we have
Okay, I don't even know. Look, I was trying to read that thing and I wasn't even listening to him talk. Because that's so many words to put on a page to just start yammering over, you know? So let's look at this. How are you flying Python? Okay. I learned it last night. Everything is so simple. Hello world is just print hello world. I don't know. Dynamic typing, white space. Come join us. Programming is fun again. It's a whole new world up here. But how are you flying? I just typed import anti-gravity. That's it. I also sampled everything in the medicine cabinet for comparison. But I think this is the typo. Python. Okay, so drugs.
Python. Absolutely love Python. So now that we have a socket, we have to ask ourselves, what kind of data are we going to send, and then what kind of data are we going to expect to receive across that socket?
Okay, I wasn't paying attention after I saw a lighthearted jab at substance abuse. Like, get out of here, bro. Don't make jokes. Don't make jokes, bro. All right, so there we go. What Python library gives access to TCP sockets? What Python library gives access to TCP sockets? We just wrote that down, didn't we? Import socket. This one, of course. Check the answer. Looks good. And submit it. All right. So now we're on to networking protocol. And we'll see you next time.